Good evening, everyone. Good evening, ma'am. Ma'am, shall we start the session, ma'am?
Yes,
Can
ma'am.
I
Sure.
start?
Sure, ma'am.
Good evening, everyone. It is with great pleasure that we welcome you to the short-term course on Think, Teach, Learn Deep, a hands-on deep learning bootcamp. We are honored to have Dr. Geetha, Assistant Professor in the Department of Computational Intelligence and SRM Institute of Science and Technology, KTR Campus, Chennai, as our distinguished speaker. This bootcamp promises to provide a practical, hands-on approach to understanding the fascinating world of deep learning, enable participants to explore advanced techniques, build models, and gain insights into the real-world application. We hope that this program will inspire curiosity, faster learning, and empower you to think deeper and learn deeper in the field of computational intelligence. We extend a warm welcome to all the participants and look forward to an engaging, insightful, and productive session. Once again, I welcome you, ma'am. I welcome you all participants.
Yes, thank you, ma'am. Am I audible?
Yes, ma'am, audible, ma'am. Your screen also visible, ma'am.
Yeah, thank you so much. Yeah, good evening, everyone. This is Geetha, working as an assistant professor in the Department of Computational Intelligence, SRM Institute of Science and Technology. It is a pleasure to welcome you all to Think Leap, Learn Leap, a hands-on deep learning workshop. So today we are going to explore one of the most exciting transformative areas of modern artificial intelligence, like deep learning. So the main goal of this workshop to help the uh, participants, participants, which were used to understand the core concepts behind the deep learning and gain practical experience in building and training the neural networks. And surely by the end of the session, surely you will learn a deep learning, what is deep learning, how it is used in popular frameworks like TensorFlow or PyTorch. So we will start with the conceptual understanding of neural networks, how they learn, what deep really means, and the role of data. And finally, after that, we will study about the hands-on activities of building simple models, experimenting with architectures, and visualizing learning processes. Finally, we will discuss the applications, challenges, and best practices in deep learning projects. So this is the agenda. So here we have to know the fundamentals of neural networks and deep learning, and build, train, and evaluate the models using real set, and understanding of overfitting, optimization, and model improvement techniques. And we can also able to develop the confidence to explore the advanced architectures of CNN, FNN, and RNN architecture, convolutional neural network, recurrent neural network, feed forward neural networks. And we will begin by the laying of the foundation, that is how to that is understanding of what deep learning really means, how it difference from traditional machine learning, how a neural network that does with the mimics with the human brain, and it is interconnected with the neurons that learn from data. So we can also discuss with uh, architecture of feed forward neural networks, and what are all the activation functions should be available in this neural networks, and what is loss functions and pack propagation functions, and how to train and evaluate the model, and so on. So here we have there are here we have the introduction to AI, artificial intelligence, machine learning, and deep learning, how it is related with one another. So normally we have three categories, right? So these CNNs are utilized. So first one, the computational neural network, we have categorized into three types, right? So that is CNN, the convolutional neural network, feed forward, and recurrent neural network. So the CNNs, the convolutional neural network, which is mainly utilized for image classification. We can also able to categorize what kind of images is that, whether it may be a leaf, or identification and detection of leaf diseases, or we can able to categorize the images of fruits or images of dog or cat. We can able to predict the classification, predict the diseases of leaf images and image classification as well. And the recurrent neural network, which is mainly utilized to for the text or uh, sentimental analysis. Okay. And for feed forward neural networks, which is used for the data prediction and the regression using this kind of networks. So the next one is the agenda, and these are all the topics we must cover today. And the next one is artificial. What is mean by artificial intelligence? So what is an artificial intelligence? We must know that it could be the broader concept of creating the machine that can think, it can act, or it can react like our humans. So it is mainly the artificial intelligence which is used to discuss, which is used to tell for designing the system that can look into other environment, and it can make decisions, or it can learn from the experience. So normally in this artificial intelligence we have the virtual assistant, right? Normally we used a Siri or Alexa, or self-driving cars, or recommendation systems, or robotics. So it can be any kind of it can able to design any kind of things like that. So we have the AI that combines the language of the computer science and mathematics, psychology, and neuroscience. So that are simulated together to create an intelligent behavior. That is why we used an AI nowadays. And second major thing is machine learning. So it is a subset of AI, and it is focused on the machines, the ability to learn from the data rather than being explicitly programmed. Okay, so we can train our models to find the patterns, or to make a decisions. So to make a decisions instead of giving the who rules, complex rules. So machine learning, it can take the powers of predicting the spams, or filter out the spam mails, or predicting the text, or fraud detection on recommendation engines. So, and we it can be the categorized of machine learning can be three types. One is the supervised, unsupervised, and reinforcement learning. If it is a supervised learning, the model that can learn from the labeled data. Suppose for example, we can able to predict the house price, so predicting the house prices. And if it is unsupervised learning, the model has to find the patterns in unlabeled data. For example, we have a segmentation of customers. And third one is a reinforcement learning. So in this model, we can learn by interacting with an environment, as well as getting the feedback. So for example, we used game playing AI, okay, robotics. So that and all the example of reinforcement learning. And third one is we focus on the deep learning. So normally it's a machine learning is a subset of AI, and deep learning is a subset of machine learning. So it uses the artificial neural networks inspired by the human brain. And this is also extract the features, and it will represent it can have the various representations of data, like images, or whether it speech or text, any kind of data. So normally the traditional deep learning models, it can also handle the data, but it cannot handle the large scale complex data. But the deep learning can handle such kind of large scale complex data, and it can achieve the state of art performance in many ways. So normally the example of such kind of deep learning that includes image recognition or facial recognition, okay, the language translation or chatbot we used nowadays, and autonomous vehicles. Okay, these are all the examples of machine learning. So why we have the deep learning discusses today? So we have the huge enormous amount of data. So the availability of big data, or the advances in the computing power like GPUs, and we have open source frameworks. Okay, so we can have in the rise of deep learning, so that can be driving force into many cutting edge technologies, from medical image analysis to generative AI tools. So that is why we used deep learning nowadays. And what about the evaluation of AI now? So we have the traditional programming to the AI programming. So traditional programming, it will require the human programmers. We are the programmers to define the explicit rules for a machine to follow. But if you have machine learning or deep learning, if you uses deep learning or machine learning, the machine learn the rules from the data itself, and the machine learn the feature representations directly from the raw data. That is why we use the deep learning. Okay, and what about the evaluation of AI from the yesterday to today, today to tomorrow? So what kind of evaluation happened in AI? So yesterday we know the foundations of or basics of AI in the year of 1950s to 2000s, and it can focus on theory or logic or symbolic reasoning. So it can have an idea to create practically as a real time, and it can have the limited data computing power, and it can have a human coded intelligence. But it will if it is that could be the yesterday's one. Now the today we are in the age of data and deep learning now. So from 2010 to present, till now, till 2030, that is we have the present. So it will be focuses on the data automation and real world applications. So we have the combination of big data, cloud computing, and deep learning. It has been transformed how the AI performs and learns. And the future of AI includes the data driven intelligence. Data driven intelligence, how the human and AI collaborate, and how the AI tools with the cloud based services. So from 2030 and 30 and beyond, that could be the future of AI. So, and it could be focused on human centered AI, or it should be the responsible, or it should be the understandable of human. It focus includes on self learning, and it will be used in a social media, and accessibility, or integrate with the quantum computing, or integrate with the biotechnology. So this is the evaluation of AI from yesterday, today, and tomorrow. Now we'll move on to the connection between the AI, ML, and DL. So AI is the broadest field. So it is mainly used to create a machine that can think, learn, or act like a humans. So many computers perform the task that the AI can make the computers normally require human intelligence. And such as, for example, it will be reasoning, or learning, or understanding the language. So normally we use the chatbot, expert system, games, and all. And ML is also to learn automatically from the experience without being explicitly programmed. Okay, so instead of the giving rules, we can use the algorithm to learn from the past data and to make a predictions or decisions. And DL, which uses the artificial neural networks inspired by the human brain to learn complex patterns from the large data sets. So the deep learning, it automatically extracts the features from the raw data. So it will enable the machines to learn hierarchical representations of a data using multiple neural network layers. For example, we have used in this face recognition in photos, voice assistants like Siri, Alexa, and self driving cars or medical image diagnosis. Shortly, we have to say AI is the science, artificial intelligence is the science, machine learning is a method, and deep learning is a technology. So that is the connections, that is a connection where we have to connect AI, ML, and DL. Now we will move on to the introduction of neural networks. As we have the neural networks that can be categorized into artificial neural networks and biological neural networks. Both it can be both natural intelligence and artificial intelligence, both working on the network of neurons. And while artificial neural network, it can have the ideas from the biological neural networks, but it could have a complex structure. And artificial networks network on artificial neural networks, that could be the model inspired by the human's brain. And it follows the feed forward mechanism where the data flows from input to output without looping anything, without looping back. Okay. So these networks consist of the layers that can receive the data, hidden layers, it can process the data, output layers, it will produce the data. So we can have the input layer, hidden layer, output layer. But the neural networks, it is a computational model inspired by the human brain works. So it can have the interconnected nodes like a neurons that can learn the patterns from the data. And it can have the connection as a mechanism. So it is that intelligent behavior, it can be achieved whenever the large number of simple computational units are worked together. And we have the deep learning model. It can emphasize the training models with the nested hierarchy of concepts, and it can have the representations that are combined together. And basically, the neural networks can be categorized into these types: feed forward neural networks, convolutional neural networks, recurrent neural networks, and now modular neural networks. And if we have the feed forward neural networks, it can have many simple functions through layers, where the layers whose output is not directly specified by the training data, which are called as a hidden layers here. And it can have the general function approximation. If it is a convolutional neural network, we have the convolution operation in place of like matrix multiplication. So it can have a sparse interactions and parameter sharing to improve the efficiency. And followed by recurrent neural network. It can have the sequential data, whether it may be a language or audio or anything. It can share the parameters across the different time steps. And while we're building the recurrent neural networks model, it can go in a depth computational graph when it is included with LSTM or GRE. And it can have the control flow of information. And finally, we have the modular neural networks. So, which can have the encoders which can be used to train or replicate their input to the output. So, normally the neural network can have three types of layers. I mean, it is made up of three main layers. One is the input layer, and second one is a hidden layer, and third one is the output layer. and it could be the architecture of feed forward neural network. So it can be in the feed forward, it can be through forward direction, right? It takes raw data as a input. Suppose for example we have an image of 128 into 3. So it can have the input neurons. You can multiply it of the pixels or GB and channel. Suppose if we have three kinds of data, weight and age. Okay, and you have to, these are all act as a neurons. For example, if you have an image in the sense, you can take it as a pixel or GB or channels, and and the input layer, it can take the raw data. But the hidden layer, it can perform the computation. It can perform the computation. It can take the neurons, applies to a weighted sum with the activation sum up with the activation functions to learn features from data. And through this output layer, it will produce the output. For example, in a binary classification, there is there is an output as a neuron. It can categorize an image like a dog or cat. Then it will be displayed as one. So, this could be the form of a feed forward neural network. It is in this input layer, hidden layer, and output layer. So the information moves in one directions from input to output. There is no feedback loop. So it contains input, hidden, and output layers. And each neuron in one layer is connected with each is connected with every neuron in the next layer. So mainly it will be used in this pattern recognition, image or speech recognition, or it will be predicting. The output is to predict the student performance based on the attendance or and marks. So this could be the form of this could be the architecture look like feed forward. If we have the CNN, convolutional neural networks, and it is specialist for images and spatial data, but it can have the convolutional layers. It can, instead of the hidden, it can have the convolutional layers. It can automatically extract the features like color or shape or edge, anything. So it will be used to reduce the manual feature extraction. So that is why we can able to categorize the images, that is image classification or object detection, whether we can have a video or kind of a photo, how many objects can be there in the video or audio, it can detect. Or for example, self-driving cars, or if we can able to use in a medical diagnosis like a tumor detection or tumor detection or face recognition in smartphones, like that we can use. If it is a RNN, it is mainly designated for the sequential data, and it can mapping of output from the previous steps that can fed back into the network, and it can pass the information to make the current decisions. And if we have a RNN, we can use that can also used to used in speech recognition, how the and stock market prediction, or we can able to use a translation or app like a Google Translator we have, right? So like that we can use. Suppose if we have a modular neural networks, if we have a modular neural networks, the information flows in one direction only, from input layer to the hidden layer to hidden layer, and hidden layer to the output layer. If you have a modular input, the input data, suppose for example height, weight, age, then the input layer has three neurons now. It could be in the first layer, right? So it will receive the raw data features from the external environment. So each neuron in this layer represents one feature or one attribute of the input data. Right? So these are all the layers. So we have the input layers, input layer, hidden layer, and output layer. So the input layer, it can have the neurons, right? It could be the first layer, and the hidden layer, it will receive the raw data, and output layer. Uh, Output layer, that is, it will produce the final result. Each neuron in the layer, it will represent the feature or attribute, right? So if we have a self-driving car, one module processes the traffic signs, and another one is uh, uh, detect any pedestrians. Okay, like that it can work. So it can also work in the complex decision making systems, and followed by the hidden layer. And the hidden layer, we can have one or more layers between the input and output layer. That is why we have a single layer framework and multi-layer perceptron network. So the layer executes a mathematical calculation through this hidden layer only. We can able to execute a mathematical calculations, or we can extract the features through the use of like a weights, bias, or activation function. And each neuron we have in this input layer, it will receive the input and apply the weight, or we can add or some of the weights, or passes through the result through an activation function. It can capture the complex patterns or relationship in the data. So the hidden layer is to be very complex learning that are more difficult to train. And output layer, it will produces the final result. So the number of output neurons, it will depends upon the task. Suppose one neuron, we can perform it as a regression function. So for example, predicting of prices. If we have users multiple neurons, in the sense we can have classification classification of identifying the handwritten images that starts from the 0 to 9. So depending on the output type, the system utilizes the activation functions such as the sigmoid, softmax, or linear. These are all the activation functions that we will discuss now later. And the next one is, and there could be an information flow. So information flow, in the sense the data moves from one direction. So the flow of information, that could be the forward propagation. So the inputs are given to the input layer. Each neuron in the hidden layer that compute the weighted sum of its inputs and applies to an activation function. The outputs from the hidden layer became the input to the output layer. That could be the next layer, right? So the output layer, it will generate the network prediction. So this could be the one-way movement of information. That is why it is called as a feed-forward neural network. So we can have input, the output of the input goes to the hidden layer, and it can compute or it can perform the activation functions, and finally they give the results to the output layer. So this one-way movement of information, that is why it is called as a feed forward, one direction, forward direction. And we have a learning process here. So even though we have to data flow from the forward direction, the learning happens using a technique back propagation. We can have back propagation. So the predicted output is compared with the actual output using the loss function. So the error is propagated backward to adjust the weight or bias using the gradient descent. So during the training, the forward pass compute the output, while the backward pass update the weights. So this is the mechanism. Suppose if we have the input data like glucose level enters throughout the input neurons, and we can through this hidden layer, we can able to find the weighted sum. Each neuron multiplies its inputs by weights and add a bias. Suppose for example z equal to suppose for example z equal to weight w1 x1 w2 plus w2 x2 and so on. And this is the we can also able to know how to compute the weighted sum, right? And In this activation function, it could be the nonlinear function. It can also able to learn complex patterns, whether it may be Rayleigh function or sigmoid function or tangent function. And we have a forward pass, that is activated output from one layer becomes input to the next layer. If we have to find the diapetes prediction, whether it will be 0 for no diapetics or 1 for diapetics patient, so that is for forward pass. If we have a backward pass, we can have the errors are propagated to adjust the weights via gradient descent. So like that we can use. And finally, we have the perceptron. So here we have a single layer network or multi-layer perceptron network. If it is a single layer network, that is for linear, and multi-layer perceptron network, that is for non-linear functions. And next one is, and we must know what is biological neurons and uh, uh, biological neurons to artificial neurons. And you can see the picture of the biological neurons, how it is related with artificial neurons. So here we have the biological neurons. It could have the biological structure, like it could be represented as a nerve cell, is the basic unit of human brain and our nervous system. It receives and processes and transmits the information through electrical and chemical signals. So we have input signals that can arrive through dendrites. And the cell body, we can have processed the signals and generates an electric impulse if it is reaches the threshold value. And the impulse travels down the axion and it passes through synapses to reach out the next neurons dendrites. So the process can be summarized. We can receive and process and transmit. We can receive, process, and transmit. Okay, so it could be pass transmit the information through the electrical and chemical signals. If we have the artificial neurons, sometimes it is called as a perceptron. So it could be the mathematical models, and here the artificial neuron, it can receive the inputs and apply the weights of W1 to N and sum them. We can perform any other linear function, whether you have to sum of all the weights or add a bias and passes the result to any activation function to produce an output. So artificial neuron is generally it should be a simplified mathematical model of a biological neuron. It is just as the human brain, and it will learn uh, it will learn the strength and weak of inputs, strength and weak of the connections that is inputs or multiplied by weight or sum up with inputs, or we can pass through any activation function, right? So we have the activation functions like Rayleigh function, sigmoid function, tan H functions. Okay, so we can finally it will produce an output. So this is the way you have to differentiate the biological neurons to artificial neurons. And we have we have the activation functions. So here we have an example of how to understand the activation functions. Simply, we have an example of student learning. So each neuron receives the information. So how the student will understand the concept, how it reacts depends on its activation function. So the activation function, the activation function decides whether the neuron activate or stay silent, whether the student understand or not. Just like how our brain reacts differently with different inputs. And why do we need activation functions? Activation functions are being flexible to the network, for example. If you are not using activation functions, then the neural network will perform only the linear calculations, like drawing a straight line, or it could not handle the complex problems with the real world data like images, speech, or emotions. It can handle with the simplex problems. If you have the activation functions, then the network becomes non-linear. It can learn from complex. It can perform the non-linear data or non-linear relationship, and it can handle with the real life. That is why we used activation functions. And the next one is, here we have the set of activation functions: sigmoid functions, tanh, rel, rectified linear unit. Sigmoid function, it converts any input value uh, into a range between 0 and 1, that is binary. So like a soft switch, if you want to deal with the probability output, like a pass or fail, a spam or not spam, or yes or no. Okay, so like that we can use. So the like that we can use to handle in terms of binary. The next one is tanh, and we know what is tanh is: hyperbolic tangent functions. It is it is zero centered output. It is mean by half the value, half the outputs or the positive, half the outputs or the negative. So it will be used to help the network faster than the sigmoid function. So it will suffer from the vanishing gradient problem whenever the input values are very high or low. So these effective when the data is entered around zero. So if you have the sigmoid function, if it is says yes or no, tan has says yes or no or somewhere in between. So it could be the balanced view, tan. So ReLU is a rectified linear unit. It is if the input is positive and the output is also positive. If the input is negative and the output is zero, it could be simple and efficient one. It can also able to compute easily, and it is also able to solve the vanishing gradient problems and for positive values. And it can handle with deep networks like CNNs or image tracks, anything. So if we have too many neurons, then output zero. If their output inputs are negative, they may stop learning, called dead neurons. So Relu is like a student who ignores the negative feedback, and it will focuses on the positive outcomes. So suppose for sometimes we can have only the negative feedback. Sometimes we can also able to stop the negative feedback, right? So like that we can use in the Relu functions. Activation functions mainly, it can give a life to a neural network, whether it can decide the neuron fires or not, however brain cells or react. We can choose the appropriate right activation function. Is like choosing the right tool for the right job for a student. It will determine how effectively our network works. Yeah. So the sigmoid functions, it's mainly for the binary decisions, for example spam detection. And tanh, we can use a balanced feature learning. It can used in a sentiment analysis. ReLU, which is used for fast and efficient processing, and it could be used in the image classification. Other than that, we can have a leaky ReLU and soft match functions. Leaky ReLU, it can avoid inactive neurons, and it could be used in the deep CNN networks. And we can have one more activation function, that is softmax, which is mainly used for the probability distribution, and it can used in the multi-class classification. So the activation functions are what make a neural network intelligent. So it can have a create a model for complex relationship, and it can decide how strongly each neuron should be. So we can choose the right activation function that can make a difference between a model of just work and who works well. Okay, so these are all the activation functions, and followed by we have these activation functions, and it could be here you can see the differences between these activation functions. Sigmoid, it could be in this output layer, and tan H hidden layer, and ReLU hidden layer, and leaky ReLU, it's based upon hidden layer, softmax output layer. So here the how the activation functions, and what could be the functional details, and what are all the pros and cons between the activation functions. So it could be the output, the advantage of sigmoid function, it can have a smooth activation between zeros to one, and it could be represented historically, and it could be used in it can have an output not zero centered, so our sigmoid outputs are always positive. If you have a tan here, it's a zero centered, half of the input positive, half of the input negative. And next one is ReLU function, it doesn't saturate, so it can have it can also have the input positive input, the output not zero centered. Okay, so like that we must able to know the range of values, the output range of values. It could be 0 to 1, here minus 1 to 1, and here it could be the output range is 0 to infinity. And the next one is, so these are all the activation functions we have, and why we need. Okay, suppose for example, these are all the activation functions, and followed by we have an loss functions and back propagation that must be used in the neural networks. So why we need loss functions and back propagation? Suppose, for example, you imagine that we are teaching a robot to throw a ball into a basket. Every time it throws, you can check how far it missed. That is a loss. Then you tell how it. Then you can we can tell how to correct it through next time. That is back propagation. Okay, so this is the difference you have. You know what is loss function and the back propagation. Loss function is how wrong the model is. Back propagation is to tell the model how to fix that mistake by adjusting the neuron weights. So a loss function is a mathematical function that calculates the difference between the predicted output to the actual target output. So it helps the network learn by providing the numerical feedback. Lower loss. Lower loss means better performance, and mean squared error. It could have the average square difference. It could be it could be sensitive for larger errors, and we can have a binary class entropy. It could be used for binary classification. Suppose if you have to develop a model, it will predict 80 percentage. That is zero point 0.8 probability of identifying the images like a cat or a dog, but the actual answer is one. Why? One in the sense, yes, it is a cat. Then the loss function measures how far the 0.8 to 1. How far the zero point 0.8 from 1. So back propagation in this sense, it is a supervised learning algorithm which is used to train the neural network model by adjusting the weights. By adjusting the weights based on the error calculated by the loss function. So we are here. We have zero point 0.8 in this, and the loss is it to 0.2. You have to how to propagate the loss of 0.2. Okay, it works in the principle of gradient descent. So it will be move in the direction that reduces the loss into the first. So the loss function, it will measure how far the prediction is from the target. Forward propagation, we have forward propagation. It will computes the prediction. Loss function, it will measure the error, and back propagation, it will correct the error and using gradient descent. So what is propagation and back propagation, and what is meant by loss function? And here we have the process. Here we have the process, that is forward pass, calculate loss, backward pass, and wait update. So here forward pass, how the data is passed through the network to generate the prediction. And we can also able to calculate the loss to determine the error, that is calculate loss. Backward propagation, how the error is propagated backward and the gradients are calculated to based upon the weight, that is backward pass. And finally, you have to update the weight by adjusting using an optimization algorithm, that is gradient descent algorithm, to minimize the loss. That could be the process between the loss function and back propagation. And next one is how to train and evaluate the neural networks. So we have the training process and preventing overfitting process. Why we need to split the data set? So we have the first step, that is during the training process, we can split up the data set and epoch and batches and optimization process. Why we have splitting the why we need to split the data? So because the model that must be learned, validate, and it must be tested on different data, not on the same examples with every time. So we can update our trained data. If it is trained and testing on the same data, it will memorize instead of understanding. So we have to train the model leading to overfitting. It occurs whenever the model learns the training data too well, and it must be able to generalize the new as well as unseen data. So the training set, which is used to train the network, for example, adjusting the weight. Suppose, and after that, we can validate the data set. If the training data set is used to tune the parameters, and which is used for checking for generalization, that is for validation. After the training and validation, we can able to test the data only at the end to evaluate the model performance. Suppose we have 10,000 images of handwritten. A handwritten image that should be 0 to 9. So we can have 10,000 images. So we have to train 8,000 images, and 1,000 images that will be validated. And through this validation only we can test the data, right? So after the validation only we can able to test the 1,000 images. So during the training only the 800 images were seen by the model, and during the validation data, it will check the model is improving without overfitting. So the test data checks the final accuracy after the training is completed. So what could be the process in the sense? Think of it, if we like if the students are preparing for an exam. So the training set is our study material. Validation set is our mock test or model test we performed, right? And test set is your final exam. Check if we have already understood the topic or not. So this is the way you have to model the model the neural networks. Okay. And we have epoch and batches. So once the data set is ready, the training begins with epoch and batches. Epoch means it could be the complete process of entire training data set through the neural network. It can have a multiple process, so every training sample that can be used. So it can, suppose if you have the network weight that can be updated multiple times, it can be based upon the size of network. So the models are trained for tens and hundreds of epochs until it has been stopped. And next one is, for example, if you train 50 epochs, it means the network has seen the entire training of 50 times. And the batch in the sense, instead of processing the entire data set at once, we can divide into small groups or called as a batches. This is why we have used batches, in the sense we can able to fit the data into memory, or we can able to update the weight. And we have the optimization process. We can able to find the best set of weights, and it can minimize the loss function. It can like adjusting the knobs of the training to get out best output. And next one is And normally we have the data set split that we can study, practice, and exam like that we can use. So this could be the draining process which can have the set of thing keywords that we can use. And next one is overfitting. Overfitting means whenever the neural network becomes too good, whenever the neural networks too good at memorizing the training data, including its noise or errors, but it fails to perform well when we set a new data or unseen data. So imagine a student who memorizes every answer from last year's question paper, but cannot handle a slightly changed question in them. So they cannot able to solve a scenario based questions which were related to the concept. So that is exactly what happens whenever a neural network overfit. And finally, we can evaluate our new feed forward neural network. So the evaluation parameters are the accuracy, precision, recall, and F1 score. And finally, we can have a confusion matrix. What kind of accuracy in the sense? TP at this true positive, FP false positive, false negative, and true negative. So the accuracy, the proportion of correctly classified instances out of the total instances, and the ratio of true positive predictions to the total predicted positives. And we have a recall that is a ratio of true positive predictions to the actual positives. And we have a f1 score that can have a mean of precision and recall. So it could have the balance between the precision and recall. And we have this confusion matrix. It can be used to describe the performance of any classification model. It can show the true positive, true negative, false positive, and false negative. So this is the way you have to evaluate the model. And next one is applications of feed forward neural networks. Nowadays, it can be used in the enormous applications in real time. Pattern recognition, image recognition. It will be able to recognize the images of handwriting or speech, and it can be used to detect the objects, and it can be used in the healthcare, disease prediction, and it can be used in this finance field like stock prediction, fraud prediction, and it can be used in the weather forecasting, rainfall or temperature prediction. It can be used to for detect the fault detection, and which must be used in the marketing like fault detection and personalized marketing. And we can also able to use predict unknown values, and it can also used to detect anomaly detection. So these are all the applications of feed forward networks. So now let us see how the model has been implemented. Here you can see, is it visible? Is that collab is visible to you?
Yes, ma'am, it is clear.
Yeah. So here we have, so here you can use Google Colab is enough to execute such kind of neural network models. So in this we can use a TensorFlow. So it's a open source deep learning platform, right? So which is used to build, train, or deploy our machine learning and deep learning models. So why we have TensorFlow, that we can use the multidimensional arrays, and we can able to flow from one to another. So we can have a framework where the data flows from one input one to another. So for that we can use a TensorFlow, and it could be mainly used for deep learning. So here we have to install by using the pip install TensorFlow. So after that, there could be an example. We have the feed-forward neural network using Keras, and we can in this example we can able to know the house price prediction. So we can have the data set from the how we can have the house data set. In that we can able to predict our price, house price, and we can also able to use pandas here, so which will be used for a tabular data. And here you can see the steps. First one is we can able to load and prepare the data set, and have mentioned the data set here. And after that we can able to perform the sequential model using keras. So it could be one after, it could be the sequential model, that could be one after another. You can build a neural network with a sequence of layers. That is why we can use a sequential model. And next one is we can compile the model through optimizer, loss function, and metrics. And finally you have to train the model, and after training we can able to visualize the results and validation over the last function. So here we have a pandas we can use for data frames, and it could be with the tabular format. And we can numpy we have used for numerical operations. We can have a mathematical and manipulations and numerical functions. For that we can use numpy library. And after that, for matplotlib, which could be used for plotting the graphs, we can have a training loss and optimization. For that we can use matplotlib. And and next one is we can use to build and training a neural networks. For that we can use keras here. So in that keras we can have through this high level API, we can able to define our model structure in terms of layers and activation functions. And the next one is here we can have a standard scalar. The standard scalar, in the sense, we can normalizes the numeric features. And we can have a housing data set that we can take it from the California housing, fetch California housing data set. We can able to load it, and it could be the sample regression data set of California house prices. And next one is we can have a sequential model. We can build a neural network with a sequence of layers, and followed by we can have a dense network that is fully connected feed forward neural network layer. Okay, so that here we used dense. Okay, so we have to download the data set first. First one is we have to load the data set, and the data set contains the information about the houses in California, like number of rooms, income level, and population level, etc. So the main goal, we have to predict the median house value. It's a regression task. So we have to get the housing data, and it could have the features. It could have the features. You can mention the number of columns in the input features. And out after that we can have that is we can have the feature names. And after that we can have a target value. And the target value is to predict our house price. It could be converted into the y series. So x series, it could be able to get the feature names, what are all the feature names or column names available in the California housing data set. And y, it could have the target value, the house price. So it will be converted into the pandas. So pandas series is so here we have 80% of training data, that is it could be representing the x and y, and 20% of testing data that could be represented as x test and y test. And we have a random state. So we have a random state 42, and it will ensure split at every time. It will ensure the reproducibility. So neural network, it can perform best whenever the features you have given in the scale, a similar scale, it could be able to find the best one. And the next one is we can have a standardized the features. So in the standardized the features, we can have a standard scalar. In standardized the features, you have suppose for example you have a mean and standard deviation. So if you have a mean as 0, a standard deviation is 1, and so on. So first one is it could be used to standardize the features in terms of scaled as well as train scaled and test scaled. And after that, here this is the way you have to build the model. And in this model architecture, we can able to create a sequential model. And here we have the layers that can be stacked one after another. So it's a straight feed forward neural network we use, so there is no branching or looping. And it could be the simplest model in this keras. And we have a dense, so we have a dense that is it is fully connected feed forward neural network. So here in this each and every neuron, this layer connects to every neuron in the next layer. So that is why we have used in this dense. And 64 neurons, 64 in the sense it could be the 64 neurons participated as the units in the layer. And we have the activation functions, ReLU activation functions, and it adds a non-linearity. And we can have a input shape, and it will specify the number of input features or columns in our data. And the next one is and we can have a shape value as your columns in the data. And we can have extrain scaled extrain scaled shape data, which gives the number of input features for the California housing data set. It can have 8 features, and this layer accepts 8 input values per sample. So, and we can have the second hidden layer, which contains a second hidden layer as 64 neurons, and which can have a ReLU activation function. And here we can also we cannot able to specify the input shape again, because the keros will automatically infers the previous output. So, and we can add the output layer, and output layer of our model, that is which has one neuron. So that is one neuron, because this is the regression problem, right? So we can able to predict a single continuous value, that could be the house price. So there is no activation function is used. In default, it could be the linear function. So now we have to build our model. So after building our model, it could be display the model by using the summary. So we have created the dense layer, dense 3, 4, 5. So the model, which could be what are all the total parameters, and what are all the trained parameters and non-trainable parameters, it could be displayed. And followed by, we have to compile the model again. So a compile method, which could be configure how the module, so the model will train. And we have an optimizer here. So how the model will update the weights, for example. And we can have a loss function, which is used to minimize, right? For we have to reduce the loss. And metrics, which can be used to measure the monitor during the training, we have to use. And this one, which is used to this function, which is used to compile the model, which can have the parameters of optimizer, loss, and metrics. So after the compilation, we can able to train our model. So we have to give the train model fit is and this method is used to train our model. It makes the model it will makes the model to be trained with adjacent weights, and which can also able to minimize the loss functions. Here the model has been trained. And we can have the data, that is scaled data, that is input features with target values. And we can have the epoch of 50. So 50, it will be number of times the model goes through the entire training data. And we have mentioned the batch size as well. So the number of samples processed before the model update the weights. And we can have the validation split as 0.2. It will reserve 20%. 0.2 represent the 20%. Here we have trained 80% of data already. So reserves the 20% of the training data for validation. It will be used to check how well the model will be organized. And next one is, so the model has been trained now. Now we have to validate, sorry, that is visualized through the training and validation. So here we have the function like loss and validation loss and model loss, and how it could be represented loss with epoch. And this could be the diagram of model loss versus modulus, that is last versus epoch. So this could be the values of how the model has been trained with validated. Here we have the plot training loss per epoch, and we can also able to identify the training versus validation curves. It could be the final graph that we can show, and it could be the slow. It could be in the it could be in the structure of final graph. And this is the way you have to train the model. So these are all the steps. First you have to import the pytouch, and after that you have to use which is this could be the model implementation of feed-forward neural network model, which is used for house price prediction. So here we have to give the data set and standardize the features, and finally you have to build the model. And after that you have to compile and train the model, and finally you have to visualize the model through by displaying plots and graphs. And the next time this could be the first application of feed forward neural network. And second one is we can have a data set of MNI data set for identification of handwritten digits. We have similarly we can work with the handwritten images. So for that we can load the data set of MNIST data set, and after that we can build a model and train the model. And after the training model you have to evaluate the model set, and one second, and which will execute one by one. So this could be the example of handwritten images which is used. And finally you have to train the model and validate the accuracy value, validate handwritten images and how much accuracy it can have, it can able to identify it. And this could be the second example. And finally you have to build the model. And second next example is speech recognition with the FNN. We can able to identify the speech converted into text, and for that we can also able to use the same kind of model. And then the next application is we can have a medical diagnosis using a feed forward neural network. And we can have the data set. You have to load the data set, and finally you have to identify the based on the parameter features we can able to identify the diagnosis. We can collect the data set like a glucose, blood pressure, or insulin, any other thing. So we can collect the data set, PIMA Indians data set, and in that you can able to predict the patient whether the person is infected by diabetics or not, anything, because we can able to use the glucose level. So based on that we can insulin. So based on that we can able to find the person is infected by diabetes or not by using 0 or 1. So we can load the PIMA data set. It includes glucose, BMA and all, and divide the data set, and we can normalize the features, and after that create a feed forward neural network model. And we can use as optimizer, binary cross entropy loss or accuracy. And it can run with the 50 Apache and 80 by 20 validation split data set, 80 20. And finally we can evaluate the model by checking the accuracy, and visualizes the data by how accuracy changes during the training. And predict after the prediction it will generate a confusion matrix and the classification report, which will produces the precision recall FN score. So this is the way you have to predict whether the patient has diabetes through binary classification using the PIMA Indian diabetes data set. Is there any doubt on this? As of now, we have seen the applications of feed-forward neural network also, what I have mentioned in this slides. Is there any doubt in this?
Dear participants, any queries? Yeah, okay. And thank you, ma'am, Thank you for your sessions. Dear participants, any queries for session 1 will continue by tomorrow, session 2. Thank you, ma'am.
Thank you, ma'am.
Tomorrow session will continue at 5:30 p.m. Same link, ma'am.
Yes, ma'am.
Yeah,
Okay.
okay. Ma'am, feedback will arrive at chat button, ma'am.
Okay, ma'am.
Shakila, ma'am. Yeah, okay, ma'am.